There is a persistent anxiety humming through IT corridors right now. You type a prompt, hit enter, and watch an AI tool generate a fully working application in seconds. The industry has a name for this: vibe coding. You describe a feature in natural language, the machine writes the code, and you run it to see if it feels right. To be fair, it feels like magic. If you are building a disposable script to parse some logs or throwing together a weekend hackathon project, vibe coding gets the job done fast. But deploying that unverified output into a critical enterprise environment introduces massive risk. When stability and data integrity are non-negotiable, relying on an AI's first guess is a recipe for silent, catastrophic failures. The core issue is known as the 80% problem. An AI agent can reliably generate about 80%. This final 20% contains the edge cases, deep architecture, and security rules that current models frequently overlook. Ignoring these details creates a mountain of technical debt that eventually breaks the system. The alternative to that chaos is a practice called Agentic Engineering. It replaces casual prompting with structured, process-driven workflows. This spectrum illustrates the difference. We aren't changing the AI model itself. We are changing how much structure surrounds it. Moving from the red zone to the blue zone means adding rigorous verification at every single step. Many engineering cultures refer to these types of quick and dirty workarounds as jugaad, but surviving as a modern engineer requires moving past these temporary shortcuts and adopting the rigorous PACA structure of agentic engineering. Building that PACA structure means relying on two distinct safety nets before any AI code reaches production: tests and evaluations, or Evals. Tests are standard. They verify deterministic code, making sure a specific input yields an exact output. Evals are different. They verify the non-deterministic parts, grading the AI on the trajectory of steps it took and the logic it used to get there. To pass those tests and evals, the AI needs deep knowledge of your specific architecture. Providing that knowledge is a discipline called context engineering. This diagram maps context into static and dynamic categories. The red box is static context, core guardrails loaded into memory, defining boundaries but carrying high cost. To balance it, the blue section is dynamic context, holding skills retrieved on demand. Carefully managing what goes into static versus dynamic memory gives the AI the exact instructions it needs, exactly when it needs them. That deliberate context is how you prevent hallucinations and build an enterprise tool you can actually trust. All of this structure boils down to one simple equation: an agent equals the model plus the harness. When an AI makes a mistake, people tend to blame the underlying model, but the raw model is just an engine. On its own, it accounts for only about 10% of a functional enterprise agent. The remaining 90% is the harness. As seen in the outer rings, it includes isolated execution sandboxes, tools, and observability pipelines. Most importantly, it contains deterministic guardrails, hard-coded rules that physically block an AI from committing a security violation. The model generates ideas, but the harness is the safety net that forces those ideas to conform to strict engineering standards. Once you build this machinery, the traditional software development lifecycle looks completely different because the bottlenecks shift. This flowchart tracks the new AI-driven cycle. The time required for actual coding collapses from weeks to minutes. Instead, the critical human bottlenecks move to the very beginning, defining precise requirements, and the very end, verifying the output through evaluation loops. We call this the factory model. It requires a completely new mental framework for a developer's daily workflow. In this model, you are no longer sweating on the assembly line. The top layer is the developer zone, where you design the specifications and guardrails. The heavy lifting happens on the factory floor below, where planning and coding agents execute your design. Modern software engineers now focus on designing the automated factory that produces and verifies the code. For decades, the developer has played the role of a conductor. You sat in your editor, manually guiding every keystroke, line by line, maintaining absolute control over the syntax. As this diagram shows on the right, the new role is the orchestrator. You define high-level goals, assign tasks asynchronously to multiple agents, and review the outcomes rather than the keystrokes. There is a lot of fear that AI will replace coders, but the reality is that the machine is just taking over the tedious translation of logic into syntax. By mastering system design and intent, engineers remain the final arbiters of quality, ensuring the software meets the rigorous demands of the production environment.